Okay, it looks like my camera on my laptop doesn't want to respond right now, so I'm going to do this without you seeing my pretty little face. But I don't know if it ever makes any sense for me to have my face on the videos anyway. But I thought maybe it lends more of a human feel to the thing. I don't know. Maybe that's just dumb. But anyway, here's homework 17 and problem 1, where we have this hoist, 4,000 pounds. It's got dimensions of 6 feet and 8 feet. I accidentally made that sound say XAB, and I replaced it. Nobody asked me yet, so I figure no one's done their homework yet at 5:40 on a Sunday night. But anyway, so there's 4 feet right here, and there's an angle of 75 degrees, and each of these pulleys has a diameter of 1 foot. So let's determine the components of the forces acting on member ABC at each pin. So let's see. Oh, there's music right there. Okay. So here I've already written the thing out. And let's proceed here. I think the thing to do is to figure out the cable tension first. That makes sense to me. Because that cable is pulling right onto here, and that's going to have a, excuse me, I'm sorry. That's going to cause a force right there, right? But so let's do an FBD of just the pulley, right? So yeah, I drew it right. Okay, so there you go. And so we're gonna have FE, which is what, 4,000 pounds, and this is going to be FT and FT. All right. So in a lot of these problems, I'll often say that the pulleys are massless and frictionless, but I think we can assume that's true right here. So you take the sum of the forces in the y direction equals 0, and 2ft minus 4,000 is equal to 0. So we know that ft was equal to 2,000 pounds. And I know you'll be tempted to just go circumvent this, bypass it, but you never know when these things are going to bite you. All right, so let's see. Where else would I want to go with this? Well, got a number of things I don't know as part of it. One is a little bit of a complicated geometry I might want to note. Is going to be what happens with this cable onto this pulley right here. So just be aware. I'm aware of it that there's a little bit of a geometry thing going on right there, because the pulleys are substantial. I should have made picked a problem where the pulleys were quite small, but I think there's going to be a little bit of a complication right there. So let me do my FBD of the big picture thing, and I'm going to use the fact that this is a 2-force member right there. That's going to help me as part of my geometry. So I'll do my best to draw this in on here, and I know that I'm going to have a reaction, and I guess I'm going to go ahead and pick it in the positive direction, even though I don't quite know that it's a positive direction, and have a sneaky suspicion it's in the negative direction. Right here, there is a line right there. I think I'm going to include the pulley. I have to, full disclosure, I haven't solved this problem yet, so I don't know if I have, if I'm going to be giving myself any kinds of trouble. So I'm going to go ahead and cut the cable right there, but leave it intact for the rest of the stuff. I think that's going to be my best strategy to give me the simplest solution. Then again, I said I don't know that for a fact, by the way. So this is authentic engineering here, where we're not just pretending to to be smart, or whatever we are. We're going to be real. Okay. And then lastly, I have a force that's coming along this line of action. And it's almost certain it's going to be this direction right there. And I'm going to call that FBD. So because this thing is going to be pulling this thing up and holding it down. So I probably did a good job by choosing this one to the right. This is going to be a competitor with that. Let me find this angle. I'll label it up here as beta. And so let's see, pull it down here. That beta is going to be equal to the inverse tan. I don't think I made this on purpose, but that might be 3, 4, 5. No, this is 4 feet, and this is 6 feet. So it's going to be 6 feet up and 4 feet over. Did I do that wrong? Let me see. No, this is 6 feet over and 4 feet up. 4. So 6 and 4. So 6 over. I'm doing it again. It's 4 over 6. Yeah, so I don't think this is a 3, 4, 5 triangle. No. 4, 6, inverse tan, 33.69 degrees. Okay. And so we could say that right there. And that's acting on the center right here. That's my beta. That's coming down. Now, this right here is where I have some heartburn. I got to decide. I know this thing is going to be tangent right here. I also know that this angle that's making right there is my theta, right? That's my same angle, which is 75 degrees. I can break this into components. And I probably want to. The trouble is that it's going to be at like a weird little angle right here. So I didn't like think that out when I was picking this problem. And it might almost be better to do like a little diagram over to the side and try to think our way through this. And you might think, well, shouldn't you have already done this? I'm like, well, you do what you can do in the time frame that you have. I think the original problem from where I got this, where I got the figure from, I think that they probably just neglected this. Right, so right there is our 75 degrees, right? And what I'm worried about is the location of it. I don't mind so much the breaking it down into components, like we have to right here. But I do mind that I don't know the dimensions of where that's going to be, right? So that's the tangent off of this thing. So I know, let's see, in the original problem, I said that the diameter, dB is equal to dC, which is 1 feet. I didn't write that in my Gibbons right up above. All right, so the diameter. So that means that this right here is 0.5 feet. And this angle right here is going to be 25 degrees. Right here. So this is my F. What I decide to call FT Y, and this is my FTX. And so here are some distances that I'm going to need to get. And like I said, I'm thinking as I'm doing the thing. So here's like a little side piece of the thing. And so if this is 0.5 right here, 0.5 times the cosine of 25, boom. 0.5 times the cosine of 25 is equal to, is equal to 0.4532 feet. And then here we're going to have 0.5 times the sine of 25 degrees is 0.2113 feet. Okay, so we'll see where we use that here in a second. Here's my FBD, and here's X and Y. This is FT is good. This is going to be the sine of 75, and FTX is the cosine. FTX is equal to FT cosine 75. All right, so we're going to take the sum of the moments about A. And we're going to be able to find FBD. So, yeah. We take, I'll take this guy first. Let's take FBD. It's only going to be the vertical direction, so it's going to be the sine. So it's going to be FBD times the sine, of beta, 33.69. And it's going counterclockwise. That's good news. And its moment arm is going to be, let's see, it's hard to fit these dimensions in here, but that's 6 feet. All right, and then we can also fit this guy back into there. That's going to be the 8 feet. Okay. So, now this guy, he is going to have a clockwise component, a counterclockwise component in the x direction. All right, so it's going to be plus our 2,000 right here times the cosine of 75, but then times 0.2113. Is that right? Yeah, because he's that's the okay. And then it's going to have a negative component. This is going to be negative right here because it's going to go clockwise down. So that's going to go minus 2,000 times the sine of 75 times 0.453. Whoop, got to be careful. It's going to be 6 minus 0.4532. And then lastly, minus 4,000 times 14. And we're going to be able to get what FBD, the force in that main thing, is going to be. And so let's try them out. Let's see what happens here. I'm going to take my 4,000 times 14 first. And then I'm going to go 2,000 times sine of 75. Kaboom. And then I'm going to take 6 and I'm going to subtract out 0.4532 from it. and multiply, and that is going to add with that. But now this one's going to subtract out, but I don't think it's going to be a lot. Cosine times it, yep. And then 0.2113. Boom. No, it is not a whole lot. It's a very small amount. So it's probably, it's like 109.4 compared to 66,000, right? So when subtracting it out, whoa, what happened here? Yeah, okay. It only came to that. All right, so now I divide by 6 and divide by the sine of 33.69. I'm really kind of concerned about yes. Boom. I get nearly 20,013 pounds. Okay. In tension. That's the force affected on there. Okay. So page 2. Let's see. Other forces we want to know off of this. This is problem 1 continued. I'll write out the other stuff later. Problem 1 continued. I'll do the sum of the forces in the x direction is equal to 0. And we say that we have RAX, okay, and then a negative FBD, which we just found to be 20,013, and take the cosine of our 33.69. We also need to take the tension, 2,000, and that's going to be times the cosine of 75 again, right? And there is nothing else in the x direction. So we're going to get an RAX is going to be 33.69 cosine times, and then 2,075 cosine times, add them together, we get 17,169 pounds. Sum of the forces in the x in the y direction. And we get RAY. And that's going upwards. So we have FBD coming upwards, so that's going plus. And that was our 20,013, I think, my recollection is. But now we're going to go the sine of 33.69, and then what we also have, but now we have downwards of our tension here, and that's going to be the sine of 75. But then we also have our load, which is 4,000. So that's going to be minus 4,000. And it looks like Jordan Speed just won. That's good. Oh, yeah, I forgot to watch it. RAY, but I will watch over the summer. I'll watch sports over the summer. It's not that time of the year. 33.69. Take the sine. Kaboom. All right. And then, but 2,000. Take 75, take the sine of that. Okay, so that this gets removed in there, minus, and the 4,000. Still, there's a positive number here, so this ends up being a negative. So I guessed this wrong, and it's negative 5,169.3, if you care, pounds, right? So therefore, let's see. So these are the forces that are acting on the piece. So we got to be careful and look at the words that are placed onto this right here. Okay, so in order to fully answer this correctly, what we need to do is also look what's taking place at the pulleys. Okay, so take a look at pulley, the FBD of pulley at B. Okay, so this is the pulley at B. And I'm going to say here are my reactions. So this is going to be R, B. I got to be careful because it is connected. The other thing is connected. So we'll just pretend this is a separate pin. RBX and RBX, RBY, and RBX. Right, so we have a cable that's coming down this way, and we have a cable that's coming down this way onto this right here, right? So this is my FT, and this is my FT acting onto here, right? So we have to decide how the pulley is putting on there. So we don't have to worry about the sum of the moments as part of this right here. That's going to totally be fine. We take it about here. Yes, these are both 0.5 feet onto here, but we have the sum of the forces in the x direction is equal to 0, right? So we have to say that RBX, which we've assumed was positive right there, and then we're going to say plus F, the 2000, right? And then we're going to have to say minus 2000, but as you'll recall from our little diagram over here, we have, and maybe I should have made this one ahead of time. Yeah, that would have been good. I didn't plan it out. This is live. That's what I said, right? It's going to be the cosine of 75 equals 0. And therefore, RBX, when taking it through there, it appears to me I've drawn it the wrong direction, right? Because I'm going to take 2,000, I'm going to take the 75 times the cosine, and I'm going to get a negative 1,482.4 pounds right there, right? So it's going the opposite direction. And by the way, this is the load. This RBX is going to be the force of the pin onto this. So this thing's going to put a pin onto there, and so that's going to be yeah, no, okay. So this is going to be the load that actually happens onto. Trying to think if I want to say this the right way. Yeah, okay, it'll be fine. Yeah, sure. So 1,482.4 pounds going that way, right there. Just like we should have said up here, it should be 5,169.3 pounds down. All right, and then so the last one right here, I'm going to take an FBD. And this is, I think, yeah, you could say, yeah, okay. This is going to be the pulley at, what did we name this one? That was C. This is at B. Right, and so we have a force coming down here, and we have a force coming down there, right? And we also have reactions coming right here, and we know that this reaction's got to be up. So it's going to be RCY, and it's going to be RCX, right? So sum of the forces in the x direction equals 0. RCX minus 2,000. So RCX is equal to 2,000 pounds, and it is pushing in that direction. So, and then we're going to have some of the forces in the y direction equal to 0, and upwards is positive, but we have, and I've drawn this wrong, obviously, right? No, I drew it right. Okay, sorry. Minus 2 times 2,000. So obviously it's going to be 4,000. RCY is 4,000 pounds and upward. Okay. So, to summarize, answers are almost better to do it with a diagram, but let's say what's going on. Trying to think of the best way to communicate this, but how I did it at each pin. All right, so at A, FAX, right? And so this is going to be the force of the pin onto the thing. It's going to be the same thing as RAX, okay? And so RAX we found out was 17,106. Let's see. Let's go to 3 sig figs from now on. I don't know. I should have been doing this all along, right there. And so it should be 5,170 pounds down at B. Okay, so we really ought to combine what we had right here at B. And how come I didn't do the sum of the forces in the y direction on this one? Sum of the forces in the y is equal to 0. I forgot. That's why. So I said that RBY minus 2,000 times the sine of 75 equals 0. So that RBY is 2,075 sine times, so that's 1,932 pounds and going upwards right there, right? All right, so the thing is, I need to write out at B. The sum at B, right there, right, is in the x direction. The forces are going to be from both this and from this, right, from this pulley and from BD. So we're going to get, man, I should do this in a separate thing. Okay. But anyway, I think I'm trying to communicate the problem the right way, so that it's people are gonna get the same answers as me. Just thinking, FBD is 20,000. I'll go negative 20,000 right here, and then times cosine of 33.69, right? And but then we're going to have those are the forces onto the bar, but then this one right here is this pushing onto this. So this one pushes onto that, so it actually gets added 1,482. So I have very little doubt that anyone is going to get this correctly, but we will try to grade it nicely, which I forgot to grade this stuff. Oh, darn. I got to get back and grade. Oh, I got so much to do. So, what did I say? Yeah, it's the cosine times that. But then I'm going to subtract out my 1482. So we're left with negative 15,170 pounds. Or 15,170 pounds. And that's that going that direction. And then the y. Okay, is going to be our 20,013 sine 33.69. And we're going to say, but this time, let's see, this one, it's going to be subtracting out our 1,932. Yeah. So 20, and you go, well, why is it subtracting out? Well, you could think of this whole thing as pushing down in the y direction, right? That's why I put the thing over here, right? So this is this thing is pulling down, so this one's pushing up, but then the overall effect of this pulley onto the bar is that it's pushing down because of that cable. So it kind of counteracts the this guy from going upwards. And I got to worry that this is going to just be confusing to people, and they're just not going to get rid of it. But I think it'll be okay. So 1,932 subtract out, I get 9,169 pounds. So we get FB, these are I'm just calling these forces that are acting on there instead of calling them reactions. In the x direction is going to be 15,170 pounds this way, and FBY is going to be 9,170 pounds that way. And then at C, I just did them up above. Those are going to be opposite of these reactions that are taking place onto this. So we got FCX is this one goes this direction, so that means it's pushing onto the beam in that direction. So you got 2,000 pounds this direction. And FCY is going to be 4,000 pounds in that direction. All right, so we're getting to the point in the semester where you're going to have to navigate some things that are confusing, but you have to think your way through them. And this is one of them. I don't think I'll take off a lot of points for this, for not getting all these things right, but I will take points off for not trying to do it. So there you go. And the video was longer than I hoped, but 33 minutes. Let's see if anybody actually watches it.